Okay, so what we're doing today is we are going to be graphing when you are given a domain, okay? You've graphed before, but you haven't really graphed this way, and basically what we're doing is the opposite of this, okay? So when we did domain and range earlier in the year, you were given a graph and you came up with a domain and range. We're kind of going the opposite way. You're going to be given the domain, and you're going to be given an equation, so it's a little bit different. And then you're going to create the graph. So it's kind of the opposite, kind of backwards of what we're doing. I really like this lesson. It will be on your quiz, so make sure you are asking questions if you are confused. So we're going to start here. We're going to look at example A. So graph -9 equals 6x minus 3y with a domain of -2, -1, and 1, and then identify the range. So first of all, domain is my what values? These are my x values, right? Excuse me. So what they're wanting me to do is take this equation, figure out the here's the domain, and figure out what it would look like, and then come up with a range. But we need to write a note over here. You see this little dotted box? It says if it is written in the domain, I want you to put its partner must be in the table and the range. And that'll make a little more sense as we start going, but I wanted to go ahead and write it so we didn't forget. When we do this, whatever information is in the domain, that's the x, so it has to have a partner, its y value, right? That partner has to be in the table you're going to make, and it has to be in the range that you're going to write, okay? And on your quiz, you're going to be given a table to use. If you don't use the table, it's not going to turn out so well for you, okay? On your homework, you need to put tables. On your notes, you're going to make a table. So if I'm going to graph this equation right here, what would you guys think I should do with it first before I tried to graph it? Okay, so let's put it in slope-intercept form. So check yours to mine when you're done. Okay, so what we're going to do is we're going to kind of think about what this graph would look like. So is this a continuous or a discrete relationship? It's discrete. Jack says discrete. Do we agree, disagree? Agree. Why do you agree? It's just written as list. They're going to be coordinate points. So we're going to make a little note over here. This is discrete, which means on a graph, what is it going to look like? Dots, okay? The biggest mistake on this lesson is like little things, okay? Y'all tend to mess up on little things with this, and a lot of little things. So you've got to be really careful. So what we need is a table. So we're going to create a table down here. And I'm going to take the domain that they gave me, and I'm going to put that in for my x values. And I need to come up with the y values. Now, really and truly, you do not have to put this equation into slope-intercept form. But is it easier to get y values that way? Yeah, okay. So we're going to sub in 2 times -2 is -4 plus 3 is -1. 2 times -1, -2 plus 3 is 1. 2 times 1 is 2 plus 3 is 5. Now this is going to look like dots, you told me, right? So this is a dot, this is a dot, this is a dot. That's what my graph is going to have, 3 individual dots. Not all of our graphs are going to look this way. So I'm going to go plot these points. -2, -1. -1, +1. And 1, 5. Now if you notice, do you see how it didn't follow a pattern necessarily? Like 0 is not part of my domain. Is that okay? Yeah. It is really easy for y'all to just magically add a dot in there because you're used to following that pattern, right? So be careful. My domain is only those 3 x values, so -2, -1, and 1. And so you don't want to add extra points. Okay, so we can kind of come back to our little thought over here. This is discrete. It should look like dots. Is that what happened? Okay, so now I'm going to go write my range. And if my domain looks like this, with 3 little points and the brackets and everything, should my range look very similar to that? Can I go and add an inequality to my range when my domain was a list? No, not going to happen. Okay, so we draw our little bracket. And I can put y equals, what are the y values here? -1, 1, and 5. So, back to this box here. If it is written in the domain, its partner must be in the table. So are there partners in the table? No. Yes. Yeah. The y values are here. And are they written in the range? Yeah. So we've done what we're supposed to do. So this is a discrete graph. Okay, the biggest mistake on discrete graphs is adding more points that you did not need. Should you connect this? That's the other big mistake. If you connect it, it is suddenly becoming a continuous graph, which it's not. It's a list up here, so it should be a list and a list here. Okay, questions on that one? All right, so let's look at 2. Tell me how 2 is different.
It's saying that the domain that x is greater than 0.
Okay, so it's got an inequality. It's greater than 0, which means it is a continuous. So we're going to put a continuous note over here. What do you think this graph is going to look like? Like, it's not dots because it's continuous. So we've looked at graphs that have been lines, line segments, rays, curves. We've looked at all types. What do you think this is going to look like? What do you think, Andrew? A ray. Why do we say ray? Several of you said ray.
Because it's going only in one direction.
So it's got a starting point, and it's getting greater than that. It's going only to one direction. So this is going to be a ray. And again, this is not something you have to write. This is my thought process here. But it helps. So when I go to do this, this one is already in slope-intercept form, correct? So I just need a table. And there's only one number written right there in my domain. So that number has to be in this table. Okay? If it's written in the domain, it has to be written in the table. Now, rule of thumb is 3 points on a table or on a graph. Okay? So if you need to write that down, 3 points on table and graph. Unless it's a discrete function and it's only like 1 or 2 points. But other than that, rule of thumb is 3 points to create a table and to create a graph. And we only have 1 point available to us at the moment. But the domain is x values greater than 0. So what do I do? Not all real numbers. What do you think? Yes. What do we think?
Like a 1.
Say it again. Cameron? No, we're doing x values. What other x values could I use?
74.
74. 1, 2, 3. Do any of those work?
225.
225 if we want it. We don't want to, but any of these work because it is x values that are greater than 0. Now, we have to think about what's going to fit on our graph, correct? So we probably want to stick with small numbers. I don't want to use a 1. Anybody know why I don't want to use a 1? It's going to give me a fraction or a decimal, right? And that's okay, and it's really not an ugly one. But why do fractions if we don't have to, right? So I'm going to use 2. And then what else should you think we should use?
4.
4. That would work, okay. Does it matter? No. Every kid in this school could pick 2 more numbers to put in this table, 2 different numbers, and it would all work out fine. but I like to use the smaller numbers. I like to use evens if I have a half because it works out nicely. So when I plug in a 0 to this function, what am I going to get? A 4. When I substitute in a 2, half of 2 is 1, 1 plus 4 is? And then when I sub in a 4, I'm going to get a 6. Now, you said this is a ray, correct? What is that starting point going to look like? An open circle or a closed circle? Why open?
Because that means it's not on that number exactly, but anything greater than that.
Okay, so it's anything greater than 0. Is the 0 included? No. So down here under my table, I like to draw a little picture of what I'm expecting I'm going to see. Again, you don't have to. This is just a thought process thing. But this is telling me I'm going to start at 0, 4 with an open circle, and I'm going to have a ray that goes in this direction. Okay, so we're going to go graph it. At 0, 4, I'm going to draw an open circle. Now, here's the deal. On a quiz or a test, if I have to guess if your circle is open or closed, I'm just going to count it wrong. Okay, so don't make me guess. Just leave it open. 2, 5, and 4, 6. And I'm going to draw that line with an arrow on the end. This is a ray. And so you can kind of look at it. Is my domain greater than 0? Yes. So we think we're on the right track. But now we have to come up with the range.
So this continuous is going to be like,
It's continuous, right? So it's still going to be an inequality.
It's probably going to have like all real numbers or infinity symbols.
Say that one. Y is greater than 4. Do we agree? Disagree? So you can look at this in two different ways. You can look at it on the graph. If I look at my y-axis, if I was to box it in, I would box in here, which means I have y values that are greater than 4. You can look at your table. Here's where it starts at 4, and what's happening to the y values? It's increasing, so they're going up, which means it's greater than. So it is y is greater than 4. Now here's where people like to go wrong. A lot of people say, well, 4 is not included, right, because it's an open circle. So then they'll start at 5. But what happened to everything between the 4 and the 5? They just chopped it off. They skipped it, right? So if it is in the domain, right up here it says it has to be in the table and in my range. And is that 0 with its partner going to be in my range here? It has to be in the range, so be careful with that. All right, questions on that one?
would you just leave it as y greater than 4?
Yep, you're done. That's all you have to do. Your domain and range, like most of the time, will look very similar. So like this one up here was a list of numbers, well, so is my range. This one up here or down here had one inequality symbol, so did my range. Okay, so they will look very similar. Occasionally they will not, but most of the time they will. Okay, so we got 2 more. Go ahead and turn the page. All right, so here's C. What's different on C?
It gives us the domain.
It gives us more. It gives us 2 parts of the domain, right? Is it continuous or discrete?
Continuous.
It's continuous, right? Because it's got an inequality or multiple inequalities, it's continuous. Is it a line, a ray, a line segment, or a curve? So it's a linear problem, so it's definitely not a curve, okay? And right now we're only doing linear stuff. Anyway, but a ray earlier had one starting value and then it went from there, right? This has a starting value and a ending value. So what is it? It's a line segment. Okay. So that's, again, it's just kind of my little note to myself that this should turn out like a line segment. And this will oftentimes help if you will do this. Okay, so do we want to put this one in slope-intercept form? Yes. So x plus y equals -1. I would suggest putting them in slope-intercept form. You do not have to, but I got y is -x minus 1. Is that correct? Okay, so we're going to make a table. And again, 3 pieces of data is kind of our rule of thumb here. Rule of thumb, yes. What's the thing? It's just kind of like that's what you do, rule of thumb. Now, go back to that original statement. If it is in the domain, it has to be in the table. So what is the first value in my domain?
2.
-2. And what is the last value in my domain? 3. But I need 3 data pieces. So I have to pick something in the middle. Does it matter what I pick?
No, because it's
0.
No. Say that again.
0.
Why would we pick 0?
So you can check the y-intercept.
0 is just glorious, and it's my favorite number, right? It's easy. So I would, if 0 is between those 2 numbers, I'd pick them every time. If 0 is not, then pick something else. Pick 5. I mean, it doesn't really matter. If 0 is not between them, 0 is nice to use. Okay, so let's do -2. What is -2 going to give me? The opposite of -2 is +2. -1 is 1. Now 0 is my favorite because it's the y-intercept. It's -1. And then the opposite of 3 is -3 minus 1 is -4. Now, you told me this was a line segment. Thank you, ma'am. So it could, because it is, which means it's going to look like this, right? Are my circles going to be closed, open? What do we got?
One of each.
One of each. So which one gets the closed circle, the shaded one? So that -2 has the equal to, so it's going to be a shaded circle. The 3 has an open circle because it does not have the equal to with it. So again, this is my mental picture. This is what I should see on this graph. So we're going to go plot them now. Connect them because this one is continuous. And remember, continuous doesn't mean it goes on forever. Continuous means it is connected from one point to the next. But if you will draw this with your table, if you will think about this information that we wrote on the side, you are going to increase your chances of getting this correct. All right, so now we have to come up with the range. And again, you can look at the graph to get the range. You can look at the table to get the range. I usually look at the table because the numbers are already done for me. I don't have to think about it much. But when we write inequalities, we start with the biggest number or the smallest number? Smallest. So what is the smallest value in my range? -4. And the largest value in my range is 1. Now this is range, so the y goes in the middle. I'm going to have 2 less than symbols, because if I write at least to greatest, they will always be less than symbols. Which one gets the line?
1.
The 1 or the -4? The 1. Okay, remember, this one had the open circle. This one has the positive circle. If your slope is negative, the inequalities, the lines will switch spots when you compare the domain to the range. Now you need to put a note here. Always write least to greatest. It says that on the previous page as well in that box. But I need your domain and your range on any problem really to be least to greatest. Makes a lot more sense that way. It's how we think about numbers. Think about a number line. We have our smallest ones on the left. Okay, we have one more. Are there any questions on C before we move on? Okay, what's different about D? Yeah, the slope is 0. It's a horizontal line, right? So is it continuous or discrete?
Continuous.
Continuous. Is it going to be a line, array, a line segment? What? Line segment. And it's a line segment because it is a starting and a stopping point. So this one I don't need to rearrange, but I am going to make a table. Thank you. So what is the first value I should put in my table? A 1. And the last one? Now this is one where I can't use 0 because 0 doesn't fall between. So does it matter?
2.
No. Okay. Kirsten says 2, so we're going to use 2. You could pick 1.5 if you want. Does it matter? No. 1.347928391.
You shouldn't.
I wouldn't, but you could. Now, what happens when I put a 1 in here? So it's really y equals 4. Isn't that really y equals 0x plus 4? So 0 times 1 is 0 plus 4 is? 0 times 2 is 0 plus 4 is? And 4 times 0 plus 4 is? 4. They're all 4s, right? So when I think about this one, you told me it was a line segment, and you were right. Are my circles opened or closed or one of both?
They're all open.
They're both open because there's no equal to on either of them, right? So I'm going to go to 1, 4 and put an open circle. Oh, that is not 1, 4, Miss David. Check the scale of the graph before you do the math, right?
Yeah.
Don't be like Miss David here. This is counting by 2s. 2, 4, 6, 8, 10, right? So 1 is actually right here. I fell for my own trap. I made this problem. And then 2, 4 is a dot, and then 4, 4 is an open circle. So it looks like a little dumbbell there. Lift weights. Barbell, dumbbell, same thing.
I literally just screwed this whole graph up.
That's okay. That's why pencils are so great in math.
Good job. So the range is going to be...
All right.
When you
Now,
bring your friend to math class,
I told you, back up here please, that when I do this, my domain and range are like most of the time going to look the same. But do you need an inequality for this domain? I mean for this range? Because you would have 4 is less than y, which is less than 4. Is that necessary? What is my range going to be? Y equals 4. That's it. You're kind of right. So the y value every time, no matter what the x, is going to be 4. That's it. So this is the very few case where your domain and range do not look similar. Okay, any questions on that one? And again, it was in my domain, the 1 and 4, so I put them in my table. And its partners are both 4, which is on my range. Okay, so check that when you're doing it.